Good afternoon, everyone. I hope you all are enjoying this Identity Shield, learning the new trends happening in the cybersecurity and how to mitigate the cyber-related risk, right? I'm sure in next 2 days, you will be learning a lot of new things about the vulnerabilities, how to mitigate those vulnerabilities at early phase. In the previous session, Pratish has given the good insights about the vulnerabilities, and if those vulnerabilities are unfixed, how those open vulnerabilities can be exploited and can harm your application as well as damage the reputation of the company. So in this session, we will explore how DevSecOps with shift left security strategy is transforming secure software delivery. I mean, embedding the security as a core element without compromising the agility and efficiency. We will also go through a DevSecOps implementation case study, how we have implemented the DevSecOps in a large MNC bank. What were the challenges and how we have mitigated, how we have enabled the security in hands of the developer. So I'm Kapil Bhandari, Senior Tech Lead with the miniOrange, and it's an honor for me to discuss this topic with you all. Okay, so I'll be referring the notes in between, so please excuse me for that. So security is a concept which we apply almost in every aspect of our daily lives, right? Even without realizing whether we are leveraging the feature of security or not. For example, we lock our mobile phone to avoid the unauthorized access, right? We keep the valuables in vault to avoid the theft. Before leaving the home, we lock all the doors and windows, right? So these are the very simple and basic actions which we do to ensure the safety and protection, right, for our personal lives. Just we implement these safeguards in our daily routine. Digital world also requires robust security measures. Why? To prevent or to protect the sensitive data, to maintain the customer trust, and to ensure the business continuity. But what happens when these security measures are not prioritized or overlooked, right? What can happen? So take an example, look at some examples, right? I have just listed down a few major incidents which have happened recently. You might have heard about these incidents: Equifax data breach, Capital One data breach, SolarWind. There are many more such examples. You might have heard about the Ames ransomware attack, Marriott hotel data breach, Heartbleed bug in the OpenSSL. So there are so on. Actually, there are many security incidents which have discovered or exploited by the hackers, and they have caused a big reputation damage to the companies, as well as they have faced hefty penalties from the government as well as the regulators, right? So if you look at why, probably the next question should be in your mind, that why these incidents have occurred and why they were not caught earlier, right? Why the attackers were able to exploit these vulnerabilities, why they have stole the data, everything, right? So there are many or various reasons behind it. In some cases, adequate security measures were not addressed. In other cases, security was treated as a secondary or afterthought or lack of continuous monitoring, right? So, I mean, there are many reasons around it. And if you see all these factors points to the traditional approach of security testing. What it means that we will do the testing or security testing at end of the SDLC. I mean, which means that we will identify the vulnerabilities late, which will cause a lot of rework, which will be costly to fix because you have to iterate the entire SDLC lifecycle again. And sometimes we don't take the security very seriously, right? I mean, we just focus on the business requirements, right? Because usually our mindset is customer ne ye business requirement दी है, we have to build that capability, and that's more than enough for us, right? So that is the mindset which we need to change. That's the culture we need to change, right? And that's where, I mean, we need a proactive, integrated security mechanism, and that's where the DevSecOps principle comes into the picture, right? So let's deep dive into the DevSecOps. What is the DevSecOps? I'm sure you might have heard about the DevOps, right? So DevOps focuses or emphasizes on the collaboration between the development team and the operation teams, right? In DevOps, we usually do the security after the testing phase, right? Once your build is complete, your build is stable, then we engage the security team. That is too late in the life cycle, right? I mean, that's the too late when you discover the security vulnerabilities, right? DevSecOps is integrating the security practice into the DevOps. That's it. Keeping the same principle benefits of the DevOps. Probably I can say the DevSecOps is an extension to the DevOps. Here the focus is collaboration, automation, efficiency, everything which we inherit from the DevOps, right? But the focus is on the security, right? I mean, how we can shift left the security instead of doing the security at the end of the life cycle or after the testing phase, or let's say after the build, or let's say after the design, right? We say that we need to shift left the security. So that's, I mean, at the heart of the DevSecOps, the shift left is the main concept, which emphasizes that we need to integrate the security at the beginning. Jitna jaldi ho sake, we need to engage the security team. We need to start analysis of security. We need to come up with the plan. What kind of security testing we need based on our NFRs, non-functional requirements. कब करनी है security, कैसे करनी है, what all tools we need to deploy to enable the security. Everything should be upfront, or everything should be at the beginning, at the start, not at the end. When I say not at the end, means just before the deployment. So that's the mindset that just after everything is finished, build ho gaya, testing ho gayi, all your functional testing is done, then we usually engage the security testing team. So that is not the case. We with this shift left security, we try to change that culture. The advantage of shift left security would be, we'll be identifying the vulnerabilities in the early life cycle. Design में पता चल जाएगा security vulnerabilities क्या है, build में पता चल जाएगा, development में पता चल जाएगा, right? Testing में पता चल जाएगा, which means when we are about to go live, there will be hardly any chances that we don't fix those vulnerabilities, right? You'd be very surprised. I have an effect. I mean, the cost of fixing a bug or vulnerability in production is 30 times more than the development, which means अगर मुझे डेवलपमेंट में अगर फिक्स कर एक कोई डिफेक्ट या एक वल्नरेबिलिटी फिक्स करने के लिए, लेट्स से इफ आई स्पेंड $1, then the same vulnerability would cost me $30 in production. So that's the average. I will also share the actual figure from my last organization, what was the cost involved when we fixed the defect or issue in production environment later, when we discuss the case study, right? So I mean, so that's the whole purpose of the shift left security. In traditional approach, we were doing the security just before the production, which means around the staging or after the test when everything is stable, right? Now we are saying that move the security to the development or to the design phase, right? So let's deep dive into the DevSecOps infinity loop, right? This is the same infinity loop which you might have seen in the DevOps. The only change is we're starting the security from the plan phase. So in the plan phase, we'll be engaging with the security team. We'll be discussing the NFRs. They will come up with the analysis. They will come up with the test plan, security test plan, tools, technology, kab, kahan, kaun sa, everything is discussed here. They also, I mean, as a collaboration. So one aspect of DevSecOps is there are 3 teams involved: development, operation, and security. And it's a shared responsibility among these 3 teams. It's not just one team who is responsible for security. So developers are also responsible for writing the secure code. Operation team is also responsible that जो deploy हुआ है वो सही है. They are responsible for monitoring the live applications, the environment, everything. And then definitely the security team will help us how better we can do the secure design. They will guide us on secure development practices, right? And they will also be doing the penetration testing and everything, right? So it's a shared responsibility between or among these 3 teams. Under plan phase, when I say we means any team, I mean the development or the operation or the security or the collaboration among these three teams, they will be doing the threat modeling also, everything, right? Build phase, this is a very critical aspect of the DevSecOps, where the developer starts writing the code, right? And we want to enable the security here. This is the first phase where आप कोड कर रहे हो, right? आप कोई आईडी यूज कर रहे हो, आपके पास में कोई जेंकिंग्स की पाइपलाइन है, राइट? पाइपलाइन आपका कोड बिल्ड कर रही है, रिपोजिटरी में डाल रही है, राइट? सो हियर we will enable or we will use the security scanner tools, the software composition analysis tool, the SaaS, DaaS, container scanning, everything. So we will integrate all these tools as part of the build. Will not limit integrating these tools to the pipelines, right? Because that is the second step. What we want to ensure that the moment you write the code, the ID should be able to prompt you that there's a vulnerability here. There's a security vulnerability here, which means we'll also enable or we will integrate the plugins, security plugins in your ID. So which means, take an example of Java, right? And if you're using the Maven build mechanism, then you have the POM. So let's say if you introduce any vulnerable dependency version, the immediately ID should be able to prompt you that this is the vulnerable version you should not use. It has, let's say, so many CVs, and this is the remediation, right? Take an example from the previous session where Pratish has listed down so many vulnerabilities: SQL injection, command injection, cross-site scripting, right? If you use those tools, SaaS tools, which is the static application security testing, if you integrate the SaaS plugin in your IDE can be IntelliJ, Eclipse, Spring STS, right? It will immediately prompt you that you need to do the input validations, you need to sanitize the input parameters, everything, right? The whole idea is fail fast. You should fail here in the build. जो भी vulnerabilities है, जो भी issues है, all those should be identified in the build phase, ताकि कम से कम issues carry forward हो, right? Test phase में जाए, right? So after build, you have the test phase where you will be doing the dynamic application testing, which means that you will try to simulate attacks to find the runtime vulnerabilities. So in build, we will be focusing more on the source code, right? I mean, let's say if you have any environment where after immediately your pipeline deploys on the test environment, you can also enable the DAST there also, right? But we usually perform the DAST in the test phase where your build is stable and it is ready for the, let's say, the system integration testing, or let's say the dev testing, right? Then you apply the DAST, which will identify the runtime vulnerabilities, which you can't identify as part of your the source code, right? Once everything is done, you are ready for release. Then you move to the deploy phase, which means your release should be secure enough. There should not be any the vulnerabilities associated to that release. Under deploy phase, you will make sure that the environment where you are going to do the prod release, that environment should be vulnerable free, which means you will be running the infrastructure scanning. You will be also reviewing the configurations. You will be reviewing the access. Only limited people should have the access, everything, right? So you will everything related to the security, right? You will perform on the deploy phase. The same security continues to the operate phase, where the operation team will continuously monitor the environment logs, everything, right? And then you have the monitor phase, and there's a continuous feedback loop from 4, 5, 6. You will be getting the feedback which will be implemented in 1, 2, 3, and then this loop goes through, right? This is all probably you might be thinking that this is all theory, right? I just wanted to start with the core concept of DevSecOps, and after this slide we will go through, or we will discuss how we have implemented the DevSecOps in a real-time example, actually. Huh? So there are a few security testing techniques which we apply. Pratish has briefly covered. So if you see nowadays, most of our applications are built using the open source, right? I would be correct if I quote stats, around 90%, 95% applications are built using the open source libraries, open source components, right? So take an example of Java, right? You are heavily dependent on a Spring Boot, Spring framework libraries, right? You are doing your level best to ensure that your code, the code which you are writing, is vulnerable free, right? But what about the vulnerabilities which you are inheriting from the open source libraries, right? There may be the library critical vulnerabilities in the open source libraries. you might have heard about the Log4j shell, Spring for shell, right? Those were 0-day vulnerabilities, right? Critical vulnerabilities, which means you have to immediately fix, right? तुम्हारी कोई गलती नहीं थी, right? But since you are using the Log4j API or the Spring framework, then that was impacting your application, right? Which means your application is vulnerable, right? So open source frameworks are very good to use, but at the same time, you need to ensure that you are using the open source version, which is vulnerable free. And that's where the software composition analysis comes into the picture, right? So it will identify all the open source which your application is using, and it will tell you that this library has this vulnerabilities. There are many industry popular tools like Snyk, SonarQube, and then they report all those security vulnerabilities in form of CVE, common vulnerability and exposure, right? It will also tell you the policy violations related the issues, license related issues, right? Whether you can use those open source libraries or not, right? This SCA is integrated as part of your ID as well as part of your pipeline, so that you can find all the open source related vulnerabilities during the development, right? So with SCA, you are covered from the open source related vulnerabilities. Now come to the SaaS part. SaaS is static application security testing, which analyzes your source code. जो कोड तुम कर रहे हो उसमें कोई vulnerabilities है क्या, राइट? उसमें कोई SQL इंजेक्शन हो सकता है क्या, उसमें कोई कमांड इंजेक्शन हो सकता है क्या? So the SaaS runs on your source code which you are writing. Again, we have, since you are writing the code, and which means you can integrate the SaaS plugin in your ID as well as the pipeline. Again, it is used for the early development, and it can identify the SQL injections and everything, right? So once you are done with the source code, you deploy your artifact into the test environment where you want to identify the runtime vulnerabilities, right? जो तुम्हें static analysis के time पे नहीं मिले, and that's where you use the DAST, dynamic application security testing. Basically, it simulates the attack, and then it checks how your application is behaving runtime. कोई memory leak है क्या, same SQL injections हो रहा है क्या, broken authentication, broken authorizations, right? This is pure automated. So there are various tools like Burp Suite, OWASP, Zap you can use to perform the DAST. Infrastructure scanning, again, just to ensure that जिस environment में तुम deploy करने वाले हो वो environment vulnerable free है क्या, right? It can be the on-premise environment as well as the cloud environment. And when I say environment, I mean the on-premise environment, it includes everything, the servers, VMs, the network, everything, right? This comes, you can run the infrastructure scanning before deployment, and you can have a continuous monitoring process where on, let's say, daily basis or weekly basis, you will run the infrastructure scanning, right? Continuous monitoring is very important aspect. Let's say आज मैंने कोई एक आर्टिफैक्ट प्रोडक्शन में रिलीज किया, vulnerable free था, right? Zero vulnerabilities, right? But what happens, कल कोई एक नई vulnerabilities आ जाए, which, let's say, कोई critical vulnerabilities आए which you need to fix. How you will identify that your live environment or the live artifact is vulnerable, right? That's where the continuous monitoring comes into the picture, right? You continuously monitoring your live artifacts. Again, you can use the SCA, the tools SonarQube or the Snyk to monitor your live environment. And it's, you might have heard about the concept of BOM, right? SBOM, software bills of material, right? Which is the inventory of all your open source libraries, the versions, everything, right? So, I mean, you just create the SBOM and then your Sonar Cube or Snyk will continuously monitor the SBOM. And let's say if there's any new vulnerabilities, then it will immediately notify you, right? You can also use the SAST for the continuous the monitoring. Now, the advanced SAST tool can also run on the binaries. So, I mean, because in your live environment, you will have the executable, right? The .class file or I mean the .java, right? But usually the SAST tool requires the source code. DAS doesn't require the source code because it runs or it uses the binary, right? So, I mean, the idea is you need to enable the continuous monitoring also so that you can identify the vulnerabilities in the live environment also, right? Okay, so now jump to the case study, how we have implemented the DevSecOps and enabled the shift left in the large bank. This case study is very close to me because I was driving the DevSecOps in my previous organization, and my team was responsible for everything what we have so far understood, right? Shift left, tool integrations, on ID, building the secure pipelines, everything, right? So let's discuss why there was need to implement the DevSecOps and the shift left strategy, right? I mean, the problem statement was not new. I mean, I'm sure if you're working in any software company or if you're working on any product company, I mean, this is the very simple problem where we do the security testing at the end, right? So it was not new in the bank also. I mean, we were having around 10 to 12 NFRs, and one of the NFRs was the security NFR, and it was mandatory. I mean, whether you have any application code level change or infrastructure change, you have to perform the security testing. There was no exception. Rest all the NFRs was optionals, right? So security testing was mandatory. I mean, and the problem was there was a central InfoSec team based out of UK, which was responsible for all kind of testing, which means the application security testing as well as the infrastructure testing, right? There was, and again here, I mean, I'm not giving any inflated story, right? I mean, the security NFR was, we were doing the security testing after, just before the live, actually, just before the prod, actually, which means at end of the life cycle. We used to raise a ticket to engage the security team. Based on their availability, security engineer assign होता था, then वो assess करता था कि किस तरह की security testing करनी है, SAST करना है, ये DAST करना है, penetration testing करनी है, infrastructure scanning करनी है, right? And that engagement usually took around 2 to 3 weeks, right? Because there was limited people in InfoSec team, right? I mean, you have 100 developers, but you hardly have around 5 to 10 InfoSec team members, right, supporting to you. And that was the central team, right? Once the engagement assessment is finalized, they were using all these tools, SCA, SAS, DAS, penetration testing, everything. So they had the tool, but the availability of those tools were limited or with the InfoSec team also only, right? And it was taking use, I mean, around 4 to 8 weeks based on the nature of the change छोटा चेंज है, बड़ा चेंज है, इंफ्रास्ट्रक्चर का चेंज है, एप्लीकेशन का चेंज है, या दोनों चेंज है, राइट? मिनिमम 4 to 8 weeks, right? And the issue with all this setup was, I mean, आप टेस्ट करके बैठे हो, राइट? Everything is okay from your perspective. The dedicated testing team has given the go ahead, right? The go approval that yes, you can now deploy this artifact in the prod environment, right? But the security team needs, let's say, 4 to 8 weeks to complete their security testing, which means the delayed time to market, which means business is getting impacted. They are not able to deliver the business values to their customers. Central team का हमेशा bottleneck रहता है, because they need to serve the whole organization, right? With the limited people. Everything was happening in silos. Application team अलग है, security team अलग है. They were responsible for running all these scans, reports immediately भेज देते थे. Application team की responsibility होती थी कि उन reports को go through करना, defects identify करना, remediation identify करना. Everything was मतलब disconnected, right? So how we tackled this problem? Let's see just one. Okay. So this was a classical case of DevSecOps and the shift left security, how we have handled this. So first of all, I mean, we analyzed how we can enable the security tools which they were using, and how we can empower the developers to perform the security, so that they don't need to wait for the central infosec team, right? What it means that, again, integrating the security tools, SCA, SAST, SonarQube, code quality analysis, DAST, everything as part of the pipelines. So we started building the secure pipelines where we integrated all these, the tools, the plugins. Along with the pipelines, we also enabled these tools into their respective IDs, so that they don't push the vulnerable code into the Git, right? Because Jenkins की pipeline तो बाद में कॉल होती थी जब Git में push हो जाता था, right? But we wanted to ensure कि the developer don't push the vulnerable code into the Git itself, right? Pre-commit पे हमने enable किया. Again, PR merge होने के time पे भी enabled कि everything is again tested, right? So that was the main idea. We empowered the developers so that they can perform the security as part of the development itself, right? We conducted, since it was new for everyone, the project team or the developers were not aware how to do secure design, how to write secure code, everything, right? So we started having the training sessions with them. We also introduced the concept of security champions. I mean, the security champion was a link between the application team and the InfoSec, so that locally they can help the application team to resolve the problems. They were also doing the triage, the vulnerability triage, everything, right? While building the secure pipeline, we introduced a concept of build breaker. What it means that we set the thresholds, right? So, I mean, whenever you see the vulnerability, I mean, the severity level is critical, high, medium, low. So we introduced that 0, 0, 5, 10. 0 critical, 0 high, 5 medium, 10 low. So this was the standard, the thresholds which we set. But again, since it was new, there was a lot of legacy code in the bank, which was written 20 years back. And the current team was not happy to take the responsibility of fixing the the vulnerabilities in the legacy code. So, I mean, we customize the thresholds based on the nature of the application and the maturity level of the team. So, let's say in a team you have some security experts, or let's say you don't have any security experts. So, based on the maturity, high, medium, low, we also customize these thresholds. We started weekly cadence meetings just to understand what is the adoption of secure pipelines, everything, right? And if they are if they are fixing any issues, because now the pipelines are enabled, your IDs are enabled with the tools, which means you have continuously getting the vulnerabilities, right? So whether you are fixing or not, whether you are increasing the vulnerability, that everything was discussed in the weekly cadence meeting, right? So after this, I mean, if you see, this is a very rosy picture that we have implemented the DevSecOps, we implemented the shift left security, we empowered the developers, tools the, everything was, I mean, immediately pipeline chalte the, you were getting a Jenkins report, इतने issues SCA में निकले, इतने issues SAST में निकले, इतने issues Sonar Cube में निकले, right? So everything was good, everything was going great, right? But there were a couple of problems after we implemented the DevSecOps, right? Because everyone was getting bombarded with the vulnerabilities, right? Which they didn't anticipate. जब मैं कोड लिखता हूँ तो मुझे 100% श्योरिटी होती है कि मैं अच्छा कोड लिख रहा हूँ, बट दैट यूजली डेवलपर्स का रॉन्ग इम्प्रेशन या अजम्पशंस रहता है, राइट? कि मैं हमेशा अच्छा कोड लिखता हूँ, राइट? सो दैट वाज अ बिग सरप्राइज फॉर एवरीवन हाउ टू मैनेज द वल्नरेबिलिटीज, राइट? सो आई मीन ओवर द period there was a common feedback which we started getting from the project team. It is good that all these tools have started telling you itni sari vulnerabilities hai, right? But this is not enough for us. What they want, and that was the requirement from them, तुम हमें बताओ कि whether we are production ready or not, whether we can go into production or not, that's it. Go no go approval. Don't tell us कि इसमें 50 vulnerabilities है, इसमें 100 vulnerabilities है. You simply tell us whether we can, this artifact, which is, let's say, tested by the testing team, or this the code which built by, let's say, very a team of expertise, right? Can we deploy this code into the production or not? Is there any risk? Are there any open vulnerabilities associated to this artifact, right? So which means, I mean, there was no unified view at the release level, because when you do a release in production, you usually have multiple modules, or let's say multiple microservices, right? And there may be cases that, let's say, out of 10, 5 को green मिल गया, लेकिन 5 को no को मिला, right? So क्या करना है अभी? Whether should I go with the release or not, right? So I mean, there were a lot of issues when we implemented this DevSecOps. If you see, all these tools simply tell you इतनी vulnerabilities है, hardly कोई remediation देता है. And this was the fact when we started using the Sonatype IQ. वो केवल ये बताता था कि ये 5 critical है, 10 medium है, right? It was not giving the remediation. Even the check marks, if I'm not wrong, अभी भी नहीं बताता कि remediation क्या है, prioritization क्या है, out of 10 मुझे priority में कितनी fix करनी है, right? Because let's say, so that I can go ahead with the prod, the live. Auto fix का कोई option नहीं था. So every developer was checking the remediation either on the Google, or let's say consulting with the security team. There was no view of historical trend for the department head. So as a department head, I was not able to see कि मेरे अंदर जितने भी projects हैं उनका consolidated vulnerability count क्या है, whether over the period it was going up or down, whether I'm increasing the vulnerability data or not. So there were a lot of the challenges and gaps which we discovered. I will take another 5 minutes. And that's where, we came up with a very unique platform uh, where we integrated all the possible tools, scanning tools, whether SonarQube, SCA, SAST, DAST, infrastructure, everything, covering all the technologies, starting from the mobile, Java, Python, Node, mainframe itself. So as single place where you can run any type of scan anytime. And the capability of this platform was not just related with the scanning tools, right? Our idea was to replace Jenkins because this tool was doing the end-to-end orchestration, what Jenkins does right now, right? So that was the original idea, but we didn't keep this platform related to the scanning. We provided lot of value-added features जो मतलब बैंक में अभी तक एग्जिस्ट नहीं करते थे, इवन इंडस्ट्री में एग्जिस्ट नहीं करते थे, बिकॉज we explored a lot of open source product as well as the Snake Sonar type. At that time, they were not giving such kind of capability, right? So with this, we introduce this platform was giving you clear go no go, whether you can go into the production or not. Simple. We introduce the concept of risk score, taking the context of application. When I say application, what it means? What is the SOX level? It's true, false. Whether it is a tier 0 application, tier 1 application, tier 2 application. Where are you going to deploy your artifact, dev, SIT, prod? And what is the network zone? Internet hai, extranet hai. So we were calculating the application context, and based on considering the application context and the known vulnerabilities, we were generating the risk score. 1 to 1000, if your risk score is less than 400, then you're good to go. If your risk score is greater than 400, then you can't go. Simple. And all these calculations, the algo, we jointly built with the InfoSec team because they were having the expertise on that area. So that was the game changer feature, that you can see the go no go at individual service level or at the release level. It was giving you the clear picture if you can go at this moment, if my application go into live or not. We also introduced the autofix feature for the open source vulnerabilities. When we built this feature, Sonar type IQ, which was our underlying tool, which was giving the SCA, they were not giving the autofix feature. With this feature, the tool will automatically fix all the vulnerabilities and it will raise a PR for you. It was very intelligent tool, having a capability of deprecated component, whether you are going with the major version, everything was built in actually. We created the complete dashboard, vulnerability dashboard, where you can, as a department head or as the project manager or as a developer, you can see the complete vulnerability count, the frequently occurring vulnerabilities, right? Let's say, if I'm managing 10 projects, it might be the case that, let's say, CV 226965 has around 50 occurrences, which means there are 50 occurrences across that 10 project, right? So everything was built as part of the platform, and we won the NESCOM Innovation of Excellence Award in 2021. It was adopted by 15K engineers across globe, and we onboarded around 10K applications as part of the initiative, right? And this last slide, so what was the impact? What value addition we have given to the business as well as the engineers or the developers? We streamlined end-to-end security process. We enabled them. We empowered them in the pipeline, in the ID, We provided the smart remediations, smart prioritizations, so that they can focus on what is critical for them to go live. We were able to identify a lot of vulnerabilities in early phase. And in terms of the fourth point was the major concern area. I mean, we were able to release the end-to-end testing, security testing lifecycle testing period from 4 to 8 weeks to, 15 to 30 minutes, maximum 1 hour actually. The remediation time, which was taking long time because there was no vulnerability database, the remediation database available in the bank. Everyone was going to the Google, or let's say consulting the security expertise to find the remediation. We created our own vulnerability database. Immediately you just give the CV number and it will give the remediations available, right? So, this was the theme of when we started the DevOps and the DevSecOps. We need the simple, faster, and the better when we do the development, or when the operation team involves, or when the security team involves. Okay, I think that's it. Yeah. Thank you very much.